Today. Thank you very much for this introduction.
Can't hear you.
Sorry, is it vision this way? Yes. So I'm delighted to be here today to share with you a collaborative study led by Professor Shimada at Meiji University. As you can see here, I will be speaking about a neurophenomenological investigation of the famous rubber hand illusion. I've divided my presentation into 4 main parts. I will start by presenting some contextual elements. Then I will present the method we used and our main results. And finally, I will briefly discuss a short additional experiment we did. So as most of you already know, the rubber hand illusion is an illusion in which a subject perceives a rubber hand as belonging to them. It relies on a multisensory integration mechanism of visual and tactile stimulation, as well as proprioceptive information, resulting in a disturbance of the sense of body ownership. That is to say, the awareness one has that their body belongs to them. Since it has been first described in 1998 by Botvinick and Cohen, it has become the primary experimental paradigm to study the sense of ownership. Typically, the occurrence of the illusion is assessed through a questionnaire to which subjects respond using a 7-item Likert scale. Then the data gathered through this questionnaire are often associated with objective measures such as the proprioceptive drift, skin conductance responses, or variations in brain activity referred through electroencephalography. These studies have led to various discoveries regarding the sense of body ownership. However, if we take a small step back, something might trigger philosophical alarm. The disturbance of the sense of ownership that occurs during the rubber hand illusion is a conscious offense lived in the first person. And yet, most rubber hand illusion studies pay little attention to the subjective phenomenal dimension of the illusion. In 2013, Valenzuela Moguillansky and colleagues made a similar observation and decided to study the subjective experience of the rubber hand illusion. They thus highlighted several limitations of this experimental paradigm as it had been used up to that point. First, first, to be a valid control condition in this framework, a condition, an experimental condition, has not to induce illusion in subjects. However, Valenzuela Moguillansky and colleagues showed that the 2 most famous control conditions, namely the asynchronous and the non-stroking condition, did in fact induce illusions in some subjects. Next, they showed that the rubber hand illusion was not a univocal experience. Not all subjects reporting having experienced an illusion reported this same experience. Therefore, it is very important to verify that precisely which phenomenon is occurring or subjects are experiencing when they claim to have experienced an illusion. Finally, Valenzuela Moguillansky and colleagues showed that the rubber hand illusion was not an instantaneous all or nothing experience, but rather it followed successive phases. They therefore proposed general diatonic structures for each of the conditions they tested. And we chose to call this a structure with phase transition model here. Here, for instance, you can see the structure of the synchronous condition, where the first phase comprises 4 subphases: perception of a tactile stimulation, then association between visual and tactile stimulation, then beginning of the incorporation of the rubber hand, which most often leads to an illusion, or violation of expectations, which might lead to an absence of the illusion. From the works of Valenzuela Moguillansky and colleagues, among too few other studies, It results that the design of experiments focusing on the rubber hand illusion should be reconsidered to integrate the phenomenological specificities of the illusion, as to be sure to reach some conclusions. Yes. Neurophenomenology is precisely a research program proposed to rehabilitate the phenomenal dimension of objects of study in their fullness in consciousness research. It's not just a question of adding first-person data to cognitive science research, but rather of rethinking cognitive science methods of investigation in such a way as to take account of the first-person data, which are the starting point and the ending point of consciousness research. It is therefore a truly revolutionary program research. We therefore chose to propose a specific neurophenomenological procedure combining elicitation interview and electroencephalography. We chose to use the method of elicitation interview to gather precise phenomenological data. It has been developed by Pierre Vermersch in 1994 and then adapted to cognitive sciences by Pierre Petit-Langin in 1999. It involves guiding naive subjects to describe their experience as precisely and as fully as possible. Then we decided to combine this data gathered through elicitation interviews with third-person EEG data, a well-known technique for its excellent temporal resolution, which had in previous studies shown some variation in rubber hand illusion-related brain activity. In our study, we included 16 healthy Japanese students that we exposed to 2 different experimental conditions, both synchronous or asynchronous stimulation. Subjects first underwent brief training to prepare them to describe their experience as precisely and as fully as possible. Then, in both conditions, subjects were first stroked randomly for about 1 minute, and then either synchronously or asynchronously for approximately 10 minutes. The elicitation interview began at the beginning of the simulation and ended with the completion of the simulation. We recorded brain activity using EEG, measured proprioceptive drift before and after stimulation, and had the subjects complete a questionnaire for each condition. Regarding data analysis, we drew inspiration from the method employed by Valenzuela Moguillansky and colleagues to identify synchronic and diachronic structures in the experiments reported during the interview. We then proposed a revised phase transition model based on the experiential categories we had identified this way. By experiential categories, we mean a class that groups fragments of interviews that share common theme. For instance, descriptions such as I feel a brush stroking my hand, or I feel something tickling my hand, were gathered under the category perception of tactile stimulation. Then, rather than comparing the entire recorded EEG signal as is typically done in EEG studies, we used our interview analysis to segment the signal by phase within each condition. On this graph, for instance, you can see the succession of phases over time for each participant during the synchronous condition. You can see that the reported experiences vary from one subject to another. I discuss more in detail the phases when presenting our main results. We then clustered all signal segments belonging to the same phase to compare phases with each other, thereby proposing a new, more detailed analysis of changes in brain activity. And also, we are still in the process of conducting functional connectivity analysis. Regarding the main results of our study, I will start by presenting the results of the synchronic and diachronic analysis. So here you can see the number of subjects who reported having an illusion per condition. Like Valenzuela Moguillansky and colleagues, we found that a significant number of subjects reported having experienced an illusion during the asynchronous condition. In terms of experiential categories, we found most of the categories identified before by Valenzuela Moguillansky and colleagues, along with 5 additional categories. First, a sense of closeness between the two hands, then an increased sensitivity on the subject's hand, an attention focused on the subject's hand, a feeling of visual familiarity toward the rubber hand, and finally, the expression of an higher order judgment of ownership. We do not have enough phenomenological data to propose firm conclusions regarding those categories, but nevertheless, they suggest, especially for the concentration category, directions of investigation regarding the role of attentional processes or top-down processes in the emergence or persistence of the illusion. Then, regarding the reported illusions, we have identified 3 distinct phenomena. The classic rubber hand illusion involves a sense of ownership of the rubber hand and the disregard of one's own hand. In other words, it appears to be a replacement of the subject's hand by the rubber hand in their body image. The second illusion that we chose to name the double hand illusion also involves a feeling of ownership toward the rubber hand, but no disregard of the subject's own hand, resulting on them having sensations in both hands. And finally, the last illusion, contact-tactile sensation, already described by Valenzuela Moguillansky and colleagues, involves perceiving a tactile sensation on the rubber hand, on their own hand, in the absence of an actual tactile stimulation, specifically in the asynchronous condition. Looking at the distribution of these types of illusions, we indeed observe that the phantom tactile sensation is unique with the asynchronous condition, while the other 2 conditions are present in both conditions. We could hypothesize that the double hand illusion is an intermediate state between recognizing or integrating visual tactile stimulation and experiencing a full rubber hand illusion. But further studies will be necessary to explore this possibility. Now moving on to the results of the diachronic analysis. The figures that you can see here indicate the probability of transitioning from one phase to another, calculated from the phases reported by the subjects during the interview. We have identified several subphases within the first phase of multisensory integration. In this synchronous condition, the first subphase consists in the perception of tactile stimulation. Then most subjects notice a congruence between visual and tactile stimulation. Then experience of faint and elusive illusory experience before experiencing a full illusion. However, sometimes there are cases where subjects experience a violation of their perceptual expectations, resulting in feelings of strangeness, discomfort, or doubt, and preventing them to experience a full illusion. Furthermore, several subjects reported focusing on the rubber hand for the illusion to emerge or persist, while other subjects reported the absence or disappearance of the illusion when focusing on their own hand. In the asynchronous condition, the reported phases are quite similar to those of the synchronous condition, except for subphase 2, which becomes subphase 2 dash, the observation of the incongruence. However, in this condition, fewer subjects experience an illusion, and the transition between focusing on the rubber hand and beginning to experience an illusion is more pronounced. Due to similarity between those structures, we chose to combine them into a revised phase transition model, aggregating both conditions. Yes, if the general structure is similar to that of Valenzuela Moguillansky and colleagues' model, one of the main innovations in the dynamic nature of phase changes that do not follow linear progression and sometimes forms loops. I will now briefly summarize the main results of our EEG analysis. Previous EEG studies have shown a reduction in alpha brain waves at frontal, central, and parietal electrodes during the rubber hand illusion. So here are all the electrodes represented with the front of the head on the top and the back of the head at the bottom. We observed a similar phenomenon as the one described in previous studies when comparing brain activity at rest to brain activity during simulation, regardless of the phase considered. However, the main novelty brought by our model is the possibility to attempt studying variations in brain activity at a finer scale, particularly by comparing this activity across phases, as you can see here on the bar graph for the beginnings are shown. So we can study finer differences between phases. These are just the beginnings, but we have observed a decrease in alpha brain waves at frontal, central, and parietal electrodes between the phase of perceiving a tactile sensation and the phase of recognizing congruence between visual and tactile stimulation during the synchronous condition. Furthermore, we observed an increase in alpha brain waves when subjects focused on either their own hand or the rubber hand in both conditions, and an increase at the onset of the illusion during the asynchronous condition. We then conducted a similar analysis of the gamma brain waves. The study conducted in 2019 by Yves and colleagues showed an increase in these waves related to the sense of body ownership. We did indeed observe an increase in gamma brain waves, regardless of the phase considered, but this increase was again more pronounced during subphase 1-4, meaning the subphase of focusing on one of the two hands. This increase was more distinctly localized at the frontal, central, and parietal electrodes in the asynchronous condition. We could here hypothesize that this difference between the conditions is linked to the increased importance of attentional and top-down processes in the asynchronous condition. Asynchronous stimulation do not facilitate multisensory integration to the extent that disrupts fully the sense of body ownership as synchronous stimulation do. This could be, yes, the emergence of an illusion under these circumstances would then be more difficult and rely more heavily on top-down attentional processes. This hypothesis supports hypothesis proposed several years ago by Petterlush and colleagues, suggesting that an unknown portion of the results attributed to multisensory integration in the rubber hand illusion might in fact be linked to top-down processes of phenomenological control, for instance. By phenomenological control, they mean the ability to generate experiences that confirm expectations of an upcoming experience. For example, some subjects would suggest an illusion in an ambiguous sensory experience, for instance, the asynchronous condition. To test this ability to modulate one's own subjective experience, they developed a phenomenological control scale. And as an additional experiment to investigate the top-down processes in the verbal and illusion, we evaluated 11 of our subjects with the phenomenological control scale in its Japanese version. We observed the correlation between PCS scores and responses to questions most correlated to the verbal and illusion according to Botvinick and Cohen. This additional small experiment suggests that it would be interesting to continue investigations to better distinguish between top-down and bottom-up processes in the verbal and illusion. And we believe that our proposal of a neurophenomenological method is a first step toward this final distinction. Thank you very much.
Questions? Please.
Thank you for the talk. That was very wonderful and informative. Also, linking nicely to the previous speaker's comments about the rubber hand illusions. I was wondering what your experience is. Well, firstly, if I understood it correctly, you're using their micro-phenomenological methodology. So I'm wondering what your experience with this method is in terms of alternatives that you could have used. So somehow my impression is that it's like a very lengthy procedure to do. I'm just wondering whether it would not have been feasible to do something like a psychometric time series. So I think like the group of Tristan Beckenstein is working with these kind of tracers, whether if you had these hypotheses for a rubber hand illusion, whether it would not be much more simple to do a study like that, also with regards to then mapping these structures back onto the EEG data, which has also been my experience, can be very messy and complicated. I had another question, but maybe it's,
and then we start with this one.
Yeah.
Thank you very much for asking. Indeed, we could have thoughts about other methods. And the aspect of the temporal resolution is a true issue in this kind of procedure because while EEG has a very, very good resolution, it's more difficult to obtain such a resolution with the interview because it takes time for subjects to answer, for instance. But it was at first rather an exploratory study, so we didn't have very precise hypotheses regarding what we would find on the phenomenological aspect. So it was quite important and interesting to choose a method that enabled us to be open to new aspects of this illusion, even if we paid off a little bit of the resolution, temporal resolution in the process. Plus, there only had one study before we were studying such in depth the subjective experience during the illusion, that of Valenzuela Moguillansky and Yves. And they did choose to use microphenomenological interviews, so we could value on this one.
Last question?
I'll go back to the slide with the phase transition model for synchronous condition. Actually, this is just because there are these clusters and they overlap across participants, so you can make actually these analyses. This is the first thing, just clarification. And the second, actually, the lines. Is it like co-occurrence, or is it just that one is a constant likely to occur after another, or they co-occur, or they are? If you can just comment on that, thanks.
Yes, each number represents the probability when being in one phase to transit to another. So, for instance, here the probability to go from subphase 1 to subphase 3 directly is of 0.13. And it depends on the overall probabilities of the interviews we conducted. So it might not reflect perfectly, and it certainly doesn't, the actual lived experience, because there is some kind of contingency in the interviews data on these aspects.